So if you remember in 7.1, 7.2, 7.3, and 7.4, all we did was we simplify rational expression. We multiply, we divide, we add, we subtract rational expression. 7.5 and 7.6 come in is now we need to solve. And just like before, to solve something, the only thing different between solving and simplifying is there's an equal sign, right? So if there's an equal sign, that's when they ask you to solve. So in chapter 7.5, to solve rational expression, we will use the LCD method. And distinguish, one thing I want to point out is please distinguish between 7.5 versus 7.4 that we did on Tuesday and Wednesday. Okay, 7.5, we need to, the first step to solve this equation is first we need to find the LCD. And basically remember the LCD is all you do is you take the denominator, how many ever denominator you have, you take them and you put them together, you multiply them together. If they happen to repeat at a different denominator, we use it one time, okay? Now, the new thing, or in step 2, we insert the numerator we insert the LCD just to the numerator. Last time we asked ourselves, what are we missing? If we're missing, we insert the numerator, we insert the denominator. In 7.5, we just insert on the numerator, and now we cancel out the denominator. This is our goal. Our goal is we want to cancel out the denominator, and once we cancel them out, we can solve for the unknown. Okay, so if you look at this item, let's take a look at this item here. You saw the step. This is what they ask you to do, is solve and check the solution. So this is our typical problem, and as you can see, very similar to before, right? Very similar to before what we have in the sense of the material. But if you look at this thing here, we would do a little bit different. And this is what I want you to ask yourself. How many different terms do we have? So if you look at this thing here, everybody see that each of the item is one term. We have an x over 4, that's one term. The 3, which is the constant, is another term. And 1 over 5 is another term. So in total, those are my terms, my different individual terms. And now, if you look at the step on the right, this is what you need to do, is you need to ask yourself, for me, this is what I do is I say, okay, this is my denominator. So the first thing I need to do is I need to find the LCD. And to find the LCD, like I mentioned to you guys, all you do is take the denominator, how many ever different denominator you have, all you do is you put them together, or in the case, you multiply them. So my two denominator is a 4 and a 5. So my LCD is, I take the 4 times the 5, that is my LCD. Okay, so 20 is my LCD. So once you do that, this is what you need to do. Step 2, you need to insert your LCD to the numerator. So in my first term, I put 20 on the numerator. My second term, I don't have the denominator, so I just put 20 next to the 3. And in my third term, I put the 20 on the numerator. Again, if you think in terms of this item, this is basically my numerator, right? I have a 1 underneath, right? The 1 underneath, so that's why the 20 is still on the numerator, because the whole number is over 1. So step 1, find the LCD. Step 2, insert the LCD to the numerator. So my LCD is 20. I put the 20 on the numerator. Now, the third step is now our goal. This is our goal, ladies and gentlemen. Our goal is we want to cancel out. The reason why we insert to the numerator is because we can cancel out with the denominator. Do you agree that 4 go into 20 is 5 times? 20 divided by 4 is 5 times. And similarly, 5 go into 20 is 4 times. So basically, this is what we want to do. This is our goal. This is our objective. Our mini objective is we want to get rid of the denominator. We don't want to have the denominator, because if you get rid of the denominator, everybody see that 4 going to 20 is 5 times 5, I have 5x. 20 and 3, that's just 20 and 3. 5 going to 20 is 4 times, so what do I have? I have 4 times 1. So this is my goal, right? I mean, my mini goal is I like to work with this problem. I don't know about you guys, but I love to work with this problem because there's no denominator. Because looking at this thing here, 5 times x is 5x, 20 times 3 will give me 60, and 4 times 1 will give me 4. This problem, all of you guys should know how to solve, because we did this in chapter 2 in the beginning of the class. So basically our goal, our mini goal, right? Our mini goal, because we know how to work with this problem, so we need to do somehow, some way, take this problem and convert it to this problem here. Because if you can convert from the original problem to this item, what do I do here? Do you agree that all I need to do is add or subtract 60 to the other side to give me 4 minus 60, and I have 5x equal to 56. And now how do I get rid of the 5? I need to divide by 5 to give me 56 divided by 5 to give me negative 6 divided by 5 to give me a negative 11.2, right? So this is the idea, or this is the objective. And again, I know it's the first time you guys see this item. Some of you saw it. Let's do one more problem. And then I will take whatever question you might have. And hopefully the second time around, you can see or whatever question you might have is a little bit clearer. So I have the 4th step up there for you guys. Let's take a look at this item. Very similar to the previous one. We have one term here, right? We have one term here, 2 term here, and 3 term here. Those are my 3 terms. And now if you look at this thing here, I have 1 denominator, 2 denominator. And again, technically there is 3, but because this thing here is a 1, we don't really care about a 1, right? Because anything over 1 is just, anything times 1 is just itself. So if you look at this thing here, everybody see that my denominator is 1, I don't really care, 8 and 16, right? So if you were to do this item here, if you were to do this thing here, and if you take 8 times 16, that's fine. If you remember, this is what we do is we need to find the LCD. And if you say, oh, Mr. Tran, earlier you tell me take the 8 times 16. And 8 times 16 to give you 128, right? If you take 8 times 16, 128. One thing is 128 is a common denominator, but it's not the least. It's not the smallest. The reason why it's not the smallest, because between 8 and 16, there is a common divider. So if you remember last time I told you, if you can see that 8 and 16, what is the common divider? The common divider is 8. 8 can go to 8 and 8 can go to 16. So if you want to find the LCD, what you can do is you can say, if you multiply this item, all you need to do is divide it by a common denominator. And if you divide this by a common, multiple, then this thing will give you 16. But again, in this case, if you look at this item here, the LCD is 16. The reason why is because there's a hidden number. If you want to use the 128, that's perfectly fine, but 16 will work out the same way, okay? Sometimes you don't want to work with a big number, but if you have a calculator, you can work with a big number, okay? So we find the LCD. Now, what do I do with the LCD? This is what we need to do is whatever term you have, you insert the LCD onto the numerator. Okay, just the numerator, unlike the other, unlike yesterday, where we insert the denominator and insert the numerator. And again, the difference between this problem versus the yesterday problem is there's an equal sign. Okay, so once we have this thing here, this is our goal, our mini goal, ladies and gentlemen. At this step, if your denominator, if you still have the denominator, you did something wrong. Okay, so everybody see 8 go into 16 is 2 times, and 16 go into 16 is 1 time, meaning I no longer have a denominator. None of my items have a denominator because that's what I want to do. I want to get rid of the denominator. And if I get rid of the denominator, everybody see that 4 times 16 is 64. 2 times 2 is 4, and 3 times 1 is 3. And this is our problem. This we can do, hopefully, right? This we can do by solving for x. How do I solve for x? Well, to solve for x, I need to subtract 64, right? To solve for x, I need to subtract 64 over here. And if I subtract 64 over here, I have to subtract 64 over here, which 3 minus 64, that will give me a negative 61. And again, if I subtract that, how do I get rid of the negative 4? To get rid of the negative 4, I need to divide by a negative 4. So negative, it's a negative 61, guys. I have a typo here. So it's not 67. We subtract 64. So 3 minus 64 is 61. And then you divide this item. So again, let me, is 61, negative 61. Okay, so it's not, it's negative 61. And again, if you divide by negative 4, you have a negative 61. You have a negative 61 over 4. Okay, so again, this thing here we subtract, not add. Someone say something. Let me see. Thank you. 15.25. Someone type it in. So again, this is what we have. Is 61 negative. Negative over negative is a positive. Again, that's the small con. When I type this thing, I type it fast, and then I did not have the time to check. Someone say negative or positive 15.25. I take his word for it. So the answer, a negative 61 over a negative 4. A negative over a negative become a positive, and that's what we have. Okay, so again, that's why if I do it on the iPad, when I write it, is the good thing is will be correct because I do it right there and then. The bad thing is a little bit messy. But if I type it, is not messy, but there's a chance that we might have a mistake. So bear with me here if we have a mistake here. So given this thing here, let me ask you guys, question would be. Question would be here, ladies and gentlemen. Any question, disregard the sign, disregard the item we have. Question with anything here. Any question with the step? Well, let's take a look at C. And we have a lot of this type of problem. And cross my finger, I don't have any more typo. But take a look at this item, same idea, same concept, right? We know that this is what we have, is we have 1 term, 2 term, and 3 terms. So that's what we have is first, I want you to identify how many terms you have. And at each term, identify your denominator. So everybody see that this is what the first thing we want to do is we want to find the LCD. And to find the LCD, this is what you want to ask yourself. How many different terms do I have? Some problem you might have 2, some problem like this one you have 3, some problem you might have 4. But identify each number, each expression is 1 term. And at each term, identify what is your denominator. In this case, the first denominator is an x, the second denominator is phi, and the third denominator is x. So to do this thing here, to find the LCD, if you remember, I told you guys last Wednesday or last Tuesday, to find the LCD, this is what we need to do is we take everything and put it together. We take everything, whatever your denominator is, we put them together. But if they happen to repeat it, as you can see, this x and this x, if they happen to repeat it at a different denominator, we only use it 1 time. We only use it 1 time, meaning we only use 1x. We don't want to double use it. Because they have a common multiple, we don't want to double use it. We only want to use it 1 time, okay? So looking at this item here, this is what my LCD is. My LCD is basically phi and an x. No, if you double use is fine. It's just that sometimes your number will be a little bit bigger. So again, this is what I have. I took this denominator, I took this denominator, and I took this denominator and I merged them together. But because they are repeated, I use it 1 time. So once I find the LCD, now I need to insert my LCD to the numerator. So if I insert this LCD, this is my LCD phi x. I put the LCD on the numerator, which is with the 1. I put the LCD with the 3. I put the LCD with the 7. We only insert onto the numerator. Don't insert to the denominator. When you have an equal sign, we don't insert to the denominator. So once we have this thing here, this is the objective. Once we have this thing here, we see the x on the numerator and the x on the denominator, we cancel them out. The phi on the numerator and the phi on the denominator, we cancel out. The x on the numerator and the x on the denominator, we cancel out. And as you can see, that is our objective. This is our objective, is whatever my denominator is. Whatever my denominator is, I no longer have a denominator because I cancel with the thing that I have on the numerator. Okay. So if I cancel this thing out, now what do I have? Do you agree that the first term I have phi and a 1, the second term I have an x and a 3, and the third term I have a phi and a 7. And that's what we have. Phi times 1 is phi, x times 3 is 3x, and phi times 7 is 35. And this, I know you all know how to solve for x here. And I know you all want to see this problem unlike you want to see, like instead of this problem, right? So that's our goal. Our goal is how can we construct, how can we take this item here? How can we take this item and get to this thing here? And to do that, we need to find an LCD. Everybody see that? And because once you have this thing here, you all see that we need to subtract phi over. We need to subtract phi over on the other side. And if you subtract phi over on the other side, you will have negative 3x equal to 35 minus phi. And if you subtract 35 minus phi, you have 30. And then you divide by a negative 3 to give you a negative 10. X is equal to negative 10. Okay. So let me pause. And this is why this is the problem that you will see a lot, which this right here. let me ask you guys question on what I have or why or how my answer is -10. Any question here, ladies and gentlemen? A little less space than the previous chapter 7.4, but it's still a few things to write, right? So let's take a look at D. If you don't have question, let's take a look at D. Let me erase all of this mistake. So same idea, go, right? Same idea. If you look at this thing here, very consistently the same. We have 1 term, 2 term, and 3 term. And now my denominator, I have 1. Let me change. I have 1 denominator here. I have the denominator here. This thing here is over 1. I don't really need to use the over 1. So if you look at this thing here, do you agree that your denominator is repeated? X minus 2 is they are the same. And if they are the same and they repeat it on a different location, reminder, we only need to use it 1 time. Okay, so the LCD is basically you take the denominator, and in this case, the denominator is x minus 2. You take this denominator and you merge them together. All you do is you merge them together, and if they happen to repeat it, we only use it 1 time. So my LCD here is just x minus 2. It's not x minus 2 and x minus 2. We merge them together, but if they repeat it, we use it 1 time. Now, once we find the LCD, what do we need to do? We need to insert the LCD to the numerator, meaning I identify that I have 3 terms. I need to insert to all 3 of them. If I have 5 terms, I need to insert to all 5 of them. In this case, I only have 3. So looking at this item, because I have 3, do you agree that this is my goal? This is my mini goal. My mini goal is the x minus 2 on the numerator and the x minus 2 on the denominator, they cancel out. The x minus 2 on the numerator and x minus 2 on the denominator, they cancel out. And this is what you have. You have 4, because the x minus 2 cancels out, plus x minus 2 times 3, and equal to 22. And now what do I do? Well, do you agree that we need to distributive the 3 times the x or the x times the 3? And again, we need to distributive the 2 times the 3 to give us a -6. -2 times 3 to give us a -6. So this is my new problem, ladies and gentlemen. My new problem is this, or 4 plus x, 3x minus 6 equal to 22. Question here, ladies and gentlemen. Any question? And again, hopefully from here is a smooth sailing. How smooth? Well, we have 4, take away 6, a smaller number, take away a bigger number. Everybody see that the smaller take away bigger number, we still have 3x minus 2 equal to 22. And if I have 3x minus 2, how do I get rid of that 2? How do I move the 2 to the other side? Well, I need to add 2 to the other side to give me 22 plus 2. Therefore, 22 plus 2 is 24. How do I get rid of the 3? I need to divide. And if I divide, I have 24 divided by 3 to give me 8. And that is my answer. The answer I'm looking for is x is equal to 8. Question? All right, since you guys don't have question, let me ask you guys to do E for me. So let's say if I give you this particular problem, see if you can do E for me. I give you 5 minutes. Um, again, hopefully I typed the step over there for you guys, which is identify your LCD. Hopefully you guys see that the LCD, this problem and the previous problem is very similar. The LCD is basically the x plus 7, right? The x plus 7, those are my denominator because they repeat it. I use it one time, so my x plus 7. What do I do with the x plus 7? I need to insert to the numerator. So again, I insert to the numerator. This is what I have. X plus 7, x plus 7, x plus 7 across the board. And now what do I need to do? Well, I can cancel this x plus 7 on top and x plus 7 on the bottom. This x plus 7 on top, this x plus 7 on the bottom. What am I left with? I left with 4x minus 12 equal to 8, open parenthesis, x plus 7. And now this is your problem, ladies and gentlemen. This problem is in chapter 2, right? That's our mini goal. Our mini goal is how can we get rid of the denominator? How can we take this and throw it away? Well, not really throw it away. How can we get rid of the denominator? We changed the look of the problem. We changed the look of the problem, but we did not change the problem, okay? Because it's solving whatever we do on one side, we have to do it on the other side. That's the solving. That's the equality, right? That's the equivalent for say. Whatever we do on one side, we have to be fair and do on the other side. I multiply by x plus 7 here. I have to multiply x plus 7 here. That's what the equation is. So once we have this thing here, all we need to do is we need to distributive the 8 in. And if I distributive the 8 in, I have ax plus 56, right? So my new problem will be 4x minus 12 equal to ax plus 56. And again, your goal is you want to move the x to one side. So for me, I move the x to the left by subtract ax to give me 4 minus 8 to give me negative 4. And then if I move the x to the left, I need to move the 12 to the right. And if I move the 12 to the right, I have negative 4x equal to 68. And then I divide this by negative 4 to give me a negative 17. So again, I hope that, since none of you guys have questions, I hope that you guys can see the step and the procedure, right? The problem itself, yes, the problem itself look complicated. The problem itself look complicated because of the fraction, and many of you got intimidated by a fraction, intimidated by a rational expression, right? And in this case, we have a rational equation. So how can you make it less intimidating? Well, get rid of it, right? We want to get rid of this denominator. So that's our goal. So if you get rid of the denominator, your problem at this one here is not as intimidated at the beginning one, right? So that's your goal, right? Your goal is get rid of the denominator so that you know how to work or how to solve for x. question here. All right, let's challenge ourselves, right? Let's challenge yourself or challenge you guys. Let's take a look at this problem here. So here come, after I build up your confidence, and that's what math is, right? We build you slowly build up your confidence, and then we give you this problem, right? And it's not hard. It's not hard. If you look at this item here, from when you glance at it, just like before, right? If you glance at this thing here, just like before, nothing new. We know that this is my denominator and this is my denominator. I know that they are repeated. So what is my LCD? My LCD is x minus 9. And if you identify your LCD, what do you do with your LCD? You just insert the LCD to the first item, insert the LCD to the second item, and insert the LCD to the third item. Again, the 36 should be black, it should be red, right? And once you do that, everybody see that my denominator at this particular location, at this particular problem, your denominator need to be disappear. If you still have some denominator, your LCD is not big enough. You need to find another LCD that's big enough so that there is no longer a denominator there. So if you have this thing here, you can see that this is what we have. We have x minus 9, that's multiplication. X minus 9 cancel out, you have 4x equal to x minus 9 cancel out, you have negative 36. What do we do? Just like before, x times x is x squared, x times 9 is 9x, my negative 4 and my negative 36. Do you agree that I have like term? What are my like term? Again, my like term is a negative 9 and a negative 9 and a negative 4. And negative 9 and negative 4, this thing will give me a negative 13x equal to 36. So why do I say we give you this thing here and I paused earlier? The reason is we have an x squared here, ladies and gentlemen. We have an x squared, and x squared is equal to something. And this thing right here, remember, in order for you to solve an x squared item, the only thing we know so far is to solve it by factor. And this go back to chapter 6. Instead of go back to chapter 2, we go back to chapter 6, which we need to set this thing equal to 0. If you remember, to solve for x squared, we need to set this thing equal to 0. And how do I set it equal to 0? Well, I need to get rid of the 36, or in this case, the negative 36. And to get rid of this thing here, I need to add over. And if I add it over, I have x squared minus 13x plus 36. Is this look familiar? X squared minus 13x plus 36. And hopefully you guys say, yes, we can factor, right? Yes, we can factor. Is that two numbers multiplied to give you 36, but add together to give you 13? Hopefully you guys see that 9 times 4 is 36. 9 plus 4 is 16. And now what do I do? Well, I need to take one of the parentheses and set it equal to 0. The other parenthesis and set it equal to 0. And how do I solve for x on this side? How do I get rid of the 9? To get rid of the 9, I need to add 9. And how do I solve for x on this side? To get rid of the 4, I need to add 4. So this is my two answer. My two answer, ladies and gentlemen, is x plus 9, or x equal to 9 and x equal to 4. So question here. And again, the reason why I say this thing here is hard is because we have to factor in order for us to solve. If you look at the previous 5 problem, my x does not have a square. My x doesn't have a square, and if the x doesn't have a square, I don't need to factor anything out. I just need to move the number to the other side and basically solve by do the opposite operation, right? And if there's an x square, the challenge come in is to solve, we need to solve it by factor. Now, if you don't have question, there is a small, tiny obstacle that we have. A small, tiny obstacle that we have is this. We need to make sure that your answer work out. I did not do this before, but if you plug in the 9 in for the x, instead of an x here, everybody see that if I put in a 9, which is, that's what I solve, right? I solve my answer, and I say one of the x, I have two answers, one of the x is equal to 9. And if I were to put a 9 here, everybody see that 9 minus 9. What happened if 9 minus 9 on the denominator? Well, 9 minus 9 is equal to 0. And what happened if we have something over 0? Remember, anything divided by 0. If we have something, whatever the number is, 12 divided by 0. Well, 12 divided by 0, remember, if the 0 on the denominator, this thing is undefined, right? So if it's undefined, we cannot have it. We cannot have the 0 on the denominator. So in this case, ladies and gentlemen, in this case, just because our item, we cannot use 9 as an answer. So we have to X this 9 out, because if you using the 9, you have an undefined item. And if it's undefined, we don't know the answer. Okay. So again, in this case, there's only one answer, and the answer is x equal to 4. So make sure on MyMATLAB, if you give them this 2 answer, they will tell you your answer is wrong, because they only accept one answer. And one answer, which is the answer is x equal to 4. Okay. So again, just because that the 9, when you plug into your original problem, is undefined. So question with F. And if you glance at G, you say, wait a minute here, Mr. Tran, right? If you glance at G, again, is look horrified, right? It's look horrified because we haven't seen 3 denominator here, right? And again, it's not that bad. Looking at this thing here, the first thing I want you to see is, what is the difference between G versus F? Well, G, my original problem right now, if I look at G, I have an x squared. And if you look at your note, if you look at all of the problem in terms of F, E, D, C, B, A, if you look at those items, none of them have x squared on the denominator, right? So if we have an x squared, and again, as always, whenever there's an x squared, you want to ask yourself, what can, or is there anything you can cancel out? So the first thing is, when you see an x squared, this is what you need to do, is you need to factor them out. And this is the easy factor. And I told you guys that this is the easy factor because this is the perfect square scenario. X times x is perfect square. 3 times 3 is 9. Is also a perfect square. And all we have is x minus 3x plus 3. So first of all, everybody see that I took this item, x squared minus 9, and I factor out to be x minus 3, x plus 3. Now, if you look at this, my new denominator, this is the 3 denominator I have. I have x minus 3, x plus 3, x minus 3, x plus 3. Everybody see that all we do is we take this item, we take this item, we take this item, we take this item, we merge them together. But if they happen to repeat at a different location, we only use it one time. Because this item right here is repeated at different location, we use one of the x minus 2 or minus 3. Because of this item repeated at one of the location or different location, we use it x plus 3. So basically we put them together. It's just that if we double, we don't want to put double the item we needed. Okay, so my LCD here, ladies and gentlemen, is just basically x plus 3, x minus 3, or x minus 3, x plus 3. That's your LCD. So if you put this thing here, this is your LCD, you put them all together, and if they repeat it at different location, we use it one time. So basically we only using one of x plus 3. We don't have to double use them. We only use one x plus 3. We don't have to double use them. The reason is once you find the LCD, you just take the LCD and you put it on the numerator. My LCD is x minus 3, x plus 3. So I put x minus 3, x plus 3 on the numerator for every single terms I have. Now, this is my goal. The reason why I do that, because x minus 3 on the bottom and x minus 3 on top, they cancel out. X plus 3 on bottom and x plus 3 on top, they cancel out. X minus 3, x plus 3. So again, like I told you guys, this is what we want, right? We want our denominator to vanish, disappear. If at this location, if your denominator did not vanish, did not disappear, we did something wrong. Your LCD is not big enough, okay? And again, looking at this item here, what do? Well, we distributed the x in. X times x will give me x squared. X times 3 to give me 3x. -1 times x to give me -1. -1 times -3 to give me +3. My 38 is on the other side. I need to combine like term. I have 3x, take away 1x, I still have 2x. And because I have an x squared, I need to move everything to one side and set it equal to 0. And if I move everything to one side and set it equal to 0, I have x squared plus 2x minus 35. And if you see, if you look at this thing here, you say, oh my God, x squared. I don't like to see x squared. Well, if there's an x squared, we need to factor. Is there two numbers multiplied to give you -35, but subtract to give you 2? And again, hopefully you guys say, yes, Mrs. Tran, 5 and 7. 7 times 5 is 35, 7 minus 5 is 2. Because the 2 is positive, the 7 got to be positive. And again, once we have this thing here, we take the first item, we set it equal to 0. We take the second item, we set it equal to 0. And this is what we have. And now looking at this item here, how do we solve for x? We subtract 7 and we add 5. So once we have this item here, once we did this item here, those are my two answers. Unlike the other one, again, if you plug in the x here, if you plug the x back up to whatever this item is, none of them is become 0 because you don't have a 3 and you don't have a 3, so none of them is become 0. So again, you're good to go. So this is the two answers we have. Both answers will work. Unlike the other one of the answer is undefined. This one here, you have the two answers. This two answer will work out. Okay. So again, let me pause a minute here. Let me ask you guys a question. All right. Again, this is, this is not really new. If you remember how to do or how to simplify fraction. But let me ask you guys to do this one for me. See if you can solve for x. Pick me a number for x when I plug it in here is equal to each other. So see if you can do this problem. Hint, the first item is you need to factor this item out. And mostly this 2 item is the factor of this thing here. But again, see if you can do this one here, factor them out, find the LCD, and then insert them in and then cancel them out. So hopefully you guys see that we have an x square, so we factor them out. And like I mentioned, most of the time, ladies and gentlemen, the factor of this thing here, if these 2 things are different, the factor of that item is the combination of those 2. And just like the previous problem, this is my denominator, this is my denominator, this is my denominator. All I need to do is put them together, merge them all together. But if they happen to repeat at the different location, I only use it 1 time. And like I say, my habit, my LCD, I put x plus 3, x plus 2. You can put x plus 2, x plus 3. Like I say, it's just a habit of mine. I put the big number first. And once you identify the LCD, again, it's a lot of writing, but this is what we do, right? We put the LCD to the numerator, we put the LCD to numerator, we put the LCD to numerator. And now why do we do that? Because the x plus 2 and x plus 2 can cancel out. The x plus 3 can cancel out. And again, all of this item can cancel out. And if you look at this thing here, the denominator disappear, vanish. And that's what we want. Right. And probably you guys stuck at this location. If you did not stuck at this location, probably is good. If you stuck at this location, it's basically, again, we need to FOIL them out. We need to FOIL them out in the sense that we need to take this x times x is x squared x times 1 is 1x, 3 times x is 3x, and 3 times 1 is 3. We combine like term, therefore this is what you should have is x squared plus 4x plus 3. And if you distribute the 3 in, you have 3 times x is 3x, 3 times 2 is 6, equal to -1. Now, what do we do from here? We need to combine like term. The 4x and the 3x will give me 7x. The 4x and the 3x will give me 7x. And that's where my 7x come from. That's where my 7x come from. And again, the 3 and the 6, that's where my 3 plus 6, that's where my 9 come from. So this is my problem. I have x squared plus 7x plus 9. And now what do I need to do if I have an x squared? How can I solve? I need to set equal to 0. And if I set it equal to 0, I need to add 1 over. I have 9 plus 1. This is my new problem, or this is the problem I need to solve. X squared plus 7 plus 10. Is there two numbers multiplied to give me 10, but add together to give me 7? X plus 5, x plus 2. And again, we need to say x plus 5 equal to 0. Therefore, and x plus 2 equal to 0. You have x minus 5 and x minus 2. And unfortunately, if you guys got to this item and you got, yes, I got it, Mr. Tran, this is not the answer. On Connect Math, this is not the answer, or not Connect Math, MyMathLab. The reason why is if you plug in -2, and again, I know the frustration if you take all this step, you do all this thing here, and then you type in your answer on your calculator, or not calculator, on your computer, you put in -2, comma, -5, and the program say no, the answer you put in is incorrect. It's just because if you plug in -2, it's just because if you plug in -2 here, how about I see that if you plug in -2 in this location, if you plug in -2 and a +2, that will cancel out, that will become 0. And if that is 0, and if the 0 is on the denominator, that will be undefined. And because it's undefined, one of them is undefined, it's make the whole thing undefined, which is we cannot use the -2. So the answer, the only answer we have is -5. Okay. But again, let me ask you guys here again. I know it's a long, you know, I kind of false advertise in the beginning, say is the problem is not long, but again, let me ask you guys in terms of the step, question with the step, question with the procedure here. Well, let's step away from this a little bit. Let's do something a little bit easier. Let's take a look at 7.6. 7.6 is very easy. Is we deal with a proportional, and the proportional, to solve for proportional, item, this is all you need to do is you need to cross multiply. You need to take this and cross multiply, meaning again, all we do is we say 3 times x plus 1 and 4 times x plus 2. So as long as you have a fraction equal to a fraction, as long as you have this item here, all you need to do is cross multiply. If you don't like this cross multiplication, that's fine. If you say, Mr. Tran, I'm good with the LCD method, can I do the LCD method here? By all means, yes. You can do the LCD method here if you want to, ladies and gentlemen. If you do the LCD method, take a look at this thing here. If you do the LCD method, what is your LCD? Hopefully you guys say that my LCD is x plus 2 and x minus 1, right? That's my LCD. My LCD is x plus 2, x minus 1. Why? Because again, I have x plus 2 on one side, x plus 2 on one side, and x minus 1 on the other side. So all I need to do is combine the two together, because there's nothing repeated. And if you combine the two together, this is what we have. We have x plus 2, x plus 2, they cancel out. X minus 1, x minus 1, they cancel out. So as you can see, it's the same as you cross multiply. If you cross multiply on this side, you have 3x plus 1, and on the other side, you have 4x plus 2. So either way you do it, either way you do it, the only reason why we cannot do this in the previous problem, the only reason why we cannot do this in 7.5 earlier is because 7.5, you don't have just a fraction equal to a fraction. In 7.5, you have something added, something equal to something, right? There's an addition, so we cannot use it. But if we have a fraction equal to a fraction, if we have a fraction equal to the fraction like 7.6, then all you need to do is cross multiply. And if you cross multiply now, this is your problem, ladies and gentlemen. There's nothing else to do other than solve for x. And to solve for x, you need to distribute the 3 in. And if you distribute the 3 in, 3 times x is 3x, 3 times 1 is 1, or in this case, 3 times negative 1 is negative 3. And 4 times x is 4x, and 4 times 2 is 8. And now how do I solve for x? If I move the x to the left, 3x minus 4, then I have a negative 1x minus 3 equal to 8. I need to move the 3 over to give me 8 plus 3 to give me 11. So negative 1x equal to 11, and then I need to divide by a negative 1 to give me x equal to negative 11. So looking at this item, this is all that you need to do in chapter 7.6, which a little bit easier than chapter 7.5, because your problem will always be proportional. Meaning if you look at B, this is what we have. We have a proportional problem, right? We have an x over 5 equal to 9 over x plus 12. And if we have this problem, as long as you have a proportional, all you need to do is cross multiply. X times x plus 12, 5 times 9. So x times x plus 12 equal to 5 times 9. And now what do you have? Well, x times x is x squared. X times 12 is 12x. And 4 times 9 is 45. Unlike the previous problem on A, in B, you guys should see by now, we have an x squared. And because we have an x squared, what do we do? Well, because we have an x squared, we need to set it equal to 0. And to set it equal to 0, I need to minus 45 to give me x squared plus 12x minus 45. Is there two numbers multiplied to give me 45, but subtract to give me 12? And hopefully you say 15 times 3. If not, 15 times 3, guys. 15 times 3 is 45. 15 minus 3 is 2. And what do? I say x plus 15 equals 0. X minus 3 equals to 0. And this is what I have. X equal to negative 15 and x equal to 3. And that's all that we need to do, or that is all that we have to do in terms of this particular problem. So in 7.6, in 7.6 is very doable. Very doable. If you look at C, same idea go. Let me ask you guys to do this problem for me. Let me ask you guys to solve this x for me, and then we will go over this item. Again, this is your problem, x over x plus 7 equal to 2 over x minus 2. So we have a fraction equal to a fraction, so we need to cross multiply. See if you can solve this one for me. And then we will go over this problem. one thing I want to point out, guys, is when you do this proportional, always bring the numerator to the bring the denominator to the numerator. Okay, don't bring the denominator numerator to the denominator. Technically, it's okay too, but just bring the denominator to the numerator as you have here, which is, again, we have x and then x minus 3. We have 2, and then we bring the x plus 7 to the other side. So now all we do is we distribute this thing in, which is x times x, we have x squared, excuse me, x times 3 or negative 3, we have negative 3x. 2 times x, you have 2x, and 2 times 7, you have 14. So we will know that in order for us to solve for x squared, we need to move everything to the x squared side. And if I move everything to the x squared side, I change in the side for the 2x, and I change in the side for 14. Over here is positive, it's become a negative 2x. Over here is positive 14, it's become a negative 14. And now what do I do? Well, I combine like term. My like term is the negative 3 and a negative 2. That will give me a negative 5. And once I have this thing here, I know that I need to factor them out. And if I factor them out, I have 7 times 2 is 14. 7 minus 2 is 5. In this case, the 7 is negative and the 2 is positive. So now this is what I have is x minus 7 equal to 0. X plus 2 equal to 0. Therefore, x equal to 7. And x equal to negative 2. Again, if you plug in 7 here, 7 plus 7 is still 14. It's not disappear. So this is the 2 answer we have. Okay, this 2 answer, if you plug it into your original problem, it will be correct. Okay, so this is what we have here, ladies and gentlemen. Question with this proportional. Question with this proportional here. The last thing I have, the last thing we have is how can you solve a word problem? How can you solve a word problem using a proportion? So if they say a 64 feet rope weight 30 pounds. So if I have the 64 feet rope, that rope will weigh 30 pounds. How many pounds will the 24 rope weight, right? So there are 2 ways to do this thing here, but the easiest way, the easiest thing that I like to do is I like to put feet over pound because that's what they give me. If I put feet over pound on one side, I have to put feet over pound on the other side. So in this case, this is what I can do, or this is what I like to do is I say, okay, if the first thing they give me is 64 feet over 30 pounds. On the second one, they give me the feet, so that will be my 24 feet equal to how many weight, which is how many pound. I don't know how much is this weight. I will put that X. And if you see that this is the proportional item, then all we need to do is, I cannot. Then all I need to do is cross multiply with this thing here and cross multiply with this thing, right? So because they are proportional, so I can cross multiply like that to give me 64 times X and 30 times 24, okay? So once I have this, that's what I have, 64 times X. And then hopefully you guys see that 34 times 20, 30 times 24 is equal to 720. And then you divide this thing here is roughly equal to 11.25 pounds. So that's one way to do it. If you want to do it this way, I think the book might tell you to do it this way. And they say if we have 64 feet rope is equal to 30 pounds. And then on the bottom, if we have 24 feet rope equal to how many pounds, which is equal to X, is the same. If you list the feet with the feet and the pound with the pound, everybody see that if you were to do it like this, you you still get the same item, right? This is what you have is you have 60 feet. They tell you that 60 feet is equal to 30 pounds. 20 feet is equal how many pounds? So I don't know. So this is what we have. And again, you can put in this way. And regardless of how you set it up, you can see that we still have 64x equal to 30 times 24. So it doesn't matter how you set up, you still have that item and you still have the same in terms of this answer. So no matter, they will give you 2 items, ladies and gentlemen. They will give you 2 items. You just set up how you want to set up in the sense that if you set this equal to the other one, then again, you have to set up in the same pattern. For me, I like to put as a fraction. The book, they like to put at a equal sign. So if they ask you, John want to go on a bike trip. He know he can travel 120 miles in 3.5 days. That's a long bike trip, right? How far will he travel? How far will John travel in 10 days, right? So if you want to, you can set up this way. You can set up 120 miles is equal to 3.5 days. So that's what we have. And now, do we know how long he traveled? Well, we don't know how long he traveled, so we put our X, but we know that he will travel 10 days, right? So if you want to set up this way, you can, in the sense that looking at this item here is basically 120 over X and 35 over 10. And then again, you can cross multiply like this. You can cross multiply like that, or if you do it this way, for me, I like to set up this way in the sense that I put 120 over 3.5, and then again, I don't know how long. That's why X, and basically the day with the day and the March with the March. And again, I just cross multiply, and I have 10 times 120 and 3.5 times X. And then I divide them to give me that if he were to ride this bike 10 days, he would travel 342.9 miles. Okay. So again, look at this item here. This is what you will see on your homework. They will say a man weighed 300 pounds on Earth. And something, how much he weigh on the moon, something like that. They will give you some unit. So you just need to set up in terms of a proportion. Question here, ladies and gentlemen. Well, if you don't have question,